Maybe I'm live now. Might be live now. Let me just see. Am I live? Let me message you guys. It says I'm live. Why am I not live? It says I'm live. Okay, now I'm live. Takes ages. I believe. Okay, now I'm live. All right. Cool. Cool. Yeah, so there's an ad. Okay, cool. I think I'm live now. Just put a one if you can hear me, and it's all good, it's all clear. Just put a one if you can hear me in the chat. Just see. Cool. Okay, good stuff, good stuff. Just want to say good evening. I hope you guys are doing well. And I've got the chat on another side, so I'm just looking left and right, left and right. But I hope you guys are doing well, and I hope paper two went well for you guys, and hopefully it wasn't too difficult. But yeah, so we've got paper three on Thursday, so I just thought we could just do a stream on stats today, and then mechanics tomorrow at 12. So yeah, we're just gonna get into some stats, but I think just a general advice, what I would recommend is especially with stats, it's quite repetitive in terms of hypothesis testing. If you can get that down, what else is there? Normal distributions, then you guys should be fine. But yeah, I've got a couple of questions. I think I've got about five that we're going to go through today. I think it should be about an hour, if not probably just over an hour, but I think it should be about that. But yeah, so what I'm going to do, and I'm going to remember this time, I'm going to go to the next scene. So scene for YT live stream, and then I'm going to go here. So now you guys should be able to see the questions that I've got. I'm just having a look at the chat again. All right. What team do you want to win the Euros? To be fair, with the streaming and the TikToks, I'm so locked out of football. But I'd say probably England. But yeah. Okay, cool. Cool. So yeah, we got Venn diagrams. And yeah, what do we think about Venn diagrams, guys? Put a zero if you think they're very tricky, very challenging, don't get them at all, or put a 10 if they're very, very easy. Let me zoom in the chat so it doesn't distract me. Okay. And Zainab, the major topics for stats are just normal distribution, that's the biggest one. Binomial distribution, discrete random variables, and obviously normal approximations. But I'll just say normal distributions and binomial distributions are the main questions. But yeah, cool. So let's have a look at this question. It says the Venn diagram shows the probabilities associated with four events A, B, C, and D. Part A says write down any pair of mutually exclusive events from A, B, C, and D. Now remember, if two events are mutually exclusive, it means that there is no intersection. So if I look at this here, I've got to say, well, part A, that what events aren't intersecting each other? We can see A and C aren't, so I could say one event is A and C. If I look at this here, these two are not intersecting, right? So they are mutually exclusive. What else is there? There's also what else is there? There's also D and B. So I'll put this in a bracket like this. That's one event. The other one's gonna be D and B, and the other one is gonna be D and C, isn't it? And that's it. Those are gonna be the three events. Does that make sense? Yeah, you can. CT, I'm gonna put a link to the actual the notes that I make where you can actually access them. It's in the descriptions of the other videos, but I'll try and see if I can put it in the chat. But yeah, cool. So that's that one done. And then part B says what does it say? It says given that the probability of B is equal to zero point 0.4, find the value of P. So again, this is just very straightforward. It's only one mark. Well, if the probability of B is 0.4, it means that this entire circle, which I'll actually do, I'll just draw this right here, like that right there. That B, this has to equal 0.4 in its entirety, right? And we already know that we've got 0.24 and 0.07. So we could just say that P is going to equal 0.4, and we're going to take away those two, 0.24 and 0.07, like that. And that's just going to be 0.4 take away. What's those two? That's 0.31, no? So that's going to be 0.09. Cool. Happy with that? Makes sense so far? Not too bad? And Magic, DeLacy, I think with the large data set, um, there's a couple documents online that you can find that just summarizes it all. Okay, cool. And that's good advice. So I could do my that's for every topic in paper 3. You'll be good. Cool. So that's done. And then part C. Let's just put part C here. Let me grab this. So it says, given also that A and B are independent, find the value of Q. So another thing as well that you should always know is the formula for independence. Because anybody told me the formula for independence? Hopefully I'm not too laggy. But yeah, I'll just do it anyway because I'm sure you guys will tell me. But I don't want to just. Then, how long will this stream be? It'll be about an hour. Be about an hour. So the formula for independence is if you've got two events, probability of A, and you times them together, then this should be equal to the intersection if they are independents, right? So it's just something you need to remember. But yeah, I'll just write it here. This is for independence. Independence. Put this here. I'm doing mechanics tomorrow. I'm doing mechanics tomorrow. Rocks on. All right, cool. So yeah, this is for independence, and if they're independent, well, let's get our expressions for A and for B. So what I'll do is the probability of A is there, so I'll just write like this now. Probability of A is there, and the probability of B we actually know is 0.4. They told us, isn't it? They told us that's 0.4 over there, so I'm gonna put it says 0.4, and the intersection of A and B is just 0.24, isn't it? Right here, 0.24. So I can get this equation here, 0.24. I remember we are looking for the value of Q. Now, the probability of A, remember, is actually equal to all of these probabilities inside, isn't it? So these right here. So the Q, the 0.24 and the 0.16. So what we can say then is that if I want to express the probability of A, then it's going to be, I'll put it in a bracket, it's going to be the Q plus those two probabilities, 0.16 and 0.24. 0.24, and this is going to be multiplied by 0.4, and this is going to equal 0.24. And then now we've got an equation just in terms of Q that we can calculate. So I'm just going to go ahead and do that. So it's not too bad. This bracket is going to be Q plus 0.4, right? Let me just double check. 16 plus 24, yeah, 0.4 times by 0.4 over 2 is equal to 2.4. And then you're just going to divide it now, aren't you? So we're going to have Q plus 0.4 is going to equal 0.24 over 0.4, and then we're just going to take it away to get what Q is. So Q is going to equal 0.24 over 0.4 minus 0.4. And I'll just put this in my calculator. I'm just double checking just to make sure stream is working all good. Okay. Okay, cool. Cool. So let me just put this in the calculator now. Put this in here. And let me get my calculator. So I'm going to do 0.24 over 0.4 minus 0.4. And that gives us, let's see, 0.2. So Q is equal to 0.2. Does that make sense? Happy with that? Just gonna let me just check the chats to see I haven't missed anything. Hold on. How does this work? Cool. Cool. I think that's all okay. Yep, everyone's got 0.2. Hi Charlie, hope you're doing well. But yeah, cool. So you've done that. And then now part C. Is that part C? No, we've done part C. That's what we just did. Part D. Got this here. Let me put this here. What I'll do, I'm going to screenshot this and I'm going to get the diagram as well. Put this here. And let me get this. And then what does it say here? Okay. So it says given further that the probability of not B, given that C happens, is equal to 0.64, find the value of R and the value of S. So this is just a conditional probability. And you guys need to remember this is very, very important, right? I'll just show you the formula. So if two events are conditional, right? I'll say probability of A given that B happens, right, is going to equal the intersection of A and B, right, out of the probability of B, right? This is something you can just memorize, but you could also just kind of think about it as well. The probability of A happening, given that B has happened, well, it has to be in the intersection point of A and B, right? And it's going to be out of B. Does that make sense, guys? But you can just memorize this. And Will Gardner, thank you very much for the £2. I really appreciate it. And just as well as that, I know that a couple of you guys did send a couple of a bit of money that I maybe didn't see while I was doing the paper, but when I was doing the time sets, I did look back. So I was trying to say thank you so much. And if I miss you sending some money, it's not intentional. I really apologize, but I really appreciate the support. But yeah, hope that all makes sense. I'm just gonna put my phone on. I thought it was on mute, but it wasn't. All right, cool. So got that there, and then now what we can do is just basically use the events that they've given to us. So we've got B dash, which is the complement of B, not B, right? And then we've got C. Yeah. So where do these two events not happen at the same time? So let me just write B, and then let me just write like this here. What I'll do is I'll just copy the exact same formula, but with those two events. Probability of B, and then like that, and then out of probability of C, right? If I just copy that, yeah? Now, firstly, where is the intersection of B not happening and C happening? Well, let's look at our diagram. If B doesn't happen, right, that's on the outside of this circle. No, this is not B in yellow, right? And well, where does C happen? C happens here. So you want to ask yourself, where do these two shaded areas overlap at the same time? And it's just for this part here, isn't it? This part right here, right? That is the only part where not B happens and also C happens as well. So what we're going to say then is that the numerator, let me just zoom out so you can see the diagram as well. The numerator is going to be R, and then this is going to be over the probability of C happening, which is R plus P. Does that make sense? And obviously we know that this is 0.64, and we also know what P is, right? P is equal to, where was P again? P was 0.09. So what we can say then is that therefore we get an equation in terms of R only. R over R plus 0.09 is equal to 0.64. Does that make sense? Let me just double check the chat just to make sure I haven't left anything. Okay, cool. Okay. Right. So now we can just solve for R. So I'm going to multiply both sides by that denominator. So it becomes R is equal to 0.64. Let me do it here. 0.64 and then R plus 0.09. And then now we can expand that and then take that away. So it becomes R is equal to 0.64R plus 0.64 times 0.09, which I don't know. So I'm going to put my calculator. 0.64 times 0.09 is equal to 36 over 265. 36 over 65. Let me just double check. Yeah. And now I'm going to take that away. So I'm going to do R take away 0.64R is going to equal 36 over 625. 625, sorry. And then what's that? That's going to be 36. It's going to be 0.36R. 0.36R is going to equal 36 over 625. And then that means that R is just going to be those two divided. 36 over 625, all divided by 0.36. So I'll put it in and see what we get. So I'll put, because I've got that already, I'm going to just put answer and then over 0.36. And that gives me 4 over 25 or 0.16. So R is equal to 0.16. Thank you very much, Massa, Mahmood, and James. Good stuff. So we've got that now. And remember, we need R and S. The only thing that's missing is S. And well, we've got every single probability now. So we're just going to take all of them away from one. So what we can say then is, well, I'll do it here. Let me just do it here, double I to get S. Because we know what R is now. So to get double I here, to get S, it's going to be 1 minus all of that. Well, the probability of A. What was probability of A again? Probability of A was 0.4, no? What was A again? Now A was 0.16 plus 0.24, which is 0.4. And then the Q was what? What was Q again? Q was 0.2, so this is 0.6. So all of this here is going to be 0.6. So we're going to take away 0.6. That's A. We're going to take away A there. Then we're going to take away this part of B, 0.07. And then we're going to take away P and R. And what was P and what was R again? P was 0.09. And R is what we just found out. So 0.09, and then take away R, which is what we just found out, which is 0.16. So putting that into the calculator is going to give me 1 take away all of that minus 0.6 minus 0.07 minus 0.09 minus 0.16. And that gives me 2 over 25 or 0.08. So we know that S is 0.08 and R is 0.16. And that's it. Little pro, well done. Good stuff. Does that make sense? We all happy with that? Let me just check as well. Oh, the rain is really bad. Hopefully my internet doesn't cut out because that happens a lot. Let me just check. But yeah, I think that's all good. Just checking. Yeah, it seems all good to me. Yeah, cool. So that's that. Not too bad of a question. And then now that's done, we're gonna go into normal approximations now. So I don't think they're too bad to be fair, but let me know what you guys think of normal approximations. But yeah, let me just check chat. Okay, cool. So I think this is all good. Guys, am I back? Hold on. End broadcast. Am I back? I'm not back. Hold on. I think I'm back now. Am I back? Am I back? Basically, okay, cool. It says I'm back. Sorry, guys. Basically, what happens is that whenever it rains heavy, my internet just drops. It just drops crazy, and then it just comes back after maybe like a minute or two. But I'm happy that the stream still goes on. That's actually really, really good. I didn't even know that happens. That's so good. I thought I had to do a whole new stream again. But yeah, cool. I'm back. So yeah, let's read this question again. So it says George throws a ball, and by the way, somebody who did somebody took me said for my internet. I appreciate it, Will. I appreciate it, Will. I'm gonna get a new one with that £2. Thank you, thank you. Okay, cool. All right. Yeah, yeah, yeah. We're gonna get to harder ones. Then we're gonna get to harder ones. Don't worry. But yeah, let's just do this. So it says George throws a ball at a target 15 times. Each time George throws the ball, target is 0.48. So remember, this is a binomial distribution. So I'm just gonna say for part A that x is binomially distributed with n to be 15, and the probability is going to be 0.48. And then these ones here is very, very easy. Probability of x is equal to 3. You're just going to punch this into your calculator. So let me punch this in and see what we get. It's going to be, you're going to go to stat, distribution, you're going to go to binomial PD because it's a point, two variable, and you're going to plug in 3, sorry. And then n is 15, and then p is 0.48, and that gives me that there 0.0197, 0.0197. That's going to be part A. Part B is asking you for probability of greater than. So we know what we need to do. Greater than or equal to 5. It's just going to be equal to 1 minus the probability of the one before it. X is less than or equal to 4. So we're going to work out that on the screen. Oh, sorry, guys. I'm so sorry. I'm so, so sorry. This is just ridiculous. I'm sorry, guys. Let me just go there. Sorry, 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 sorry. Sorry, I'm looking at the screen. Sorry, 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 sorry. I'm still getting used to this software. So apologies, apologies, apologies. Okay, cool, 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 cool. You guys can see now, guys. This is a lot. This whole streaming thing, I'm new to it. I'm really new to it. I'm sorry. I'm sorry. I'm really sorry, guys. But yeah, I'm just gonna go through. I'll just run through that again quickly because I think this is okay anyway. So first one was x is equal to 3. Again, gonna plug this in, so I'll just show you what I did here. So let me go to how do I go? I think it's equals. So I just went to binomial PD. X is 3, n is 15, and p is 0.48. Plug that in, I get that number there, 0.0197 to three significant figures. So that's fine. And then this one, we're gonna do 1 minus probability of x is less than 4, isn't it? So I'm gonna get this here, and then I'm gonna change this line. I need to go to binomial CD now because it's an inequality I'm dealing with. So I'm gonna go down here to 1, and then 2 variable, and then I'm gonna do 4, and then I'm gonna do the same thing, and I get that there, right? So therefore, I'm gonna have equal to 1 minus, and then it's gonna be all of that, and that's for 4, isn't it? So that's gonna be 0.07, and then 898, blah blah blah, like that. And then now let's just see, putting this into my calculator now. So I'm gonna just go to normal calculation answer. I've still got that number stored. 1 minus answer gives me 0.92. Let me just check because I've got a couple of different answers. Let me just check that though. I think that's okay though. Let me just check. Oops. Yeah, that seems all good for me. It's okay. That's what I have it. But yeah, that seems fine. We happy that does make sense? Just double check though. Whoops. Trying to go to the live stream. Yeah. Okay. Cool. So it'd be 0.92 um 01, like that. Cool. Happy that? Yeah, all good. All right, brilliant. And then now, part B says George now throws the ball at the target 250 times. Use a normal approximation to calculate the probability that he will hit the target. So whenever you're dealing with a normal approximation, have I got it here? I thought I had something here. Let me just see if I can find it. I think I've got it in solutions. If I got it here. Oh no, I think it's here. Give me a sec, guys. I've got solutions here because there was something I wanted to show you. Do I have it here? Yeah, this thing. This is what I wanted to grab. Let me grab this here. So copy and then put this. I thought I already had this already, but this is something that you just need to know for normal approximations, right? It's super easy. Put this here. So it says if n is large and p is close to zero point 0.5, then the binomial distribution can be approximated by the normal distribution where n is mu is the mean and sigma squared is the standard deviation. And you're just going to use these formulas. So just literally just need to memorize these. Yeah. So doing this, let's plug these in and see what we get. So for mu, if we're plugging this in for part B, mu is going to equal n and p. So George now throws the ball 250 times. So I'm going to put 250 here. And then p is 0.48, isn't it? So we'll times by 0.48. And to be fair, what I should actually do, the first thing I should do is actually define the new normal distribution now, isn't it? So let me just move this here and then bring this down. And I'll just say that y, this is a new distribution, is going to equal the normal approximation of the distribution of x. That's what you should do first, to be fair. Now, I'm going to plug that in and see what I get. So 250 times 0.48. 250 times 0.48 is, that is 120. Yep. So this is going to be our new mu 120. And then our sigma is going to be the square root of np, which is mu. So I'm going to put 120 here, multiplied by 1 minus the probability of 0.48. So I'll put that in and see what I get. So that's going to give me square root of 120 and then bracket 1 minus 0.48. And that gives me that number there. So I'll just write that as 2 times root 390 over 5. So that is the standard deviation. And now we can just use our normal approximation, can't we? So we're just going to say, and to be fair, I'll square this because maybe this will be better if I put the variance instead. 62.4. Yeah. So I'm going to say that the variance, which is sigma squared, is going to be 62.4. And that means that a distribution for y, I'm going to say y is going to be normally distributed with mu, which is 120, and our variance is going to be 62.4. Right? Does that make sense, guys? Happy with that? Yeah. So now, remember, the question asked us for use the normal approximation to calculate the probability that he will hit the target more than 110 times, right? So what I like to do when I'm doing a normal approximation, right, is I just always write the actual probability in terms of binomials in a binomial sense, which is going to be x is more than, what was it, 110, right? And what I always do first is when I'm approximating it, remember you've got to do a continuity correction, right? So because it's more than 110, well, what does that mean in terms of an actual binomial sense? That's going to be x is greater than or equal to 111, isn't it? The next one. And then because I need to apply a continuity correction, just think of the boundary, right? We need to get to this number here and we need to find out what the lower and upper bound is, right? So the lower bound of 111, right? I need to include it, right? So what would round to 111? It's going to be approximately a p here, and I'm going to put y now for the normal approximation is going to be greater than, and then the lower bound of this one is going to be 110.5. So that's what I'm going to calculate. Does that make sense? And Lil Pro, well done. Yep, cool. So yeah, all we're going to do now is just plug this into our normal distribution and see what we get. So yeah, I'm going to get my calculator and put this in, and this will give me let me put this in. Distribution 7 and a normal CD, and then it's going to be the lower bound is going to be 110.5, and then the upper bound I always just choose a really big number. I just choose 10 to the 10 like that. Whoops, 10 to the 10 like that. And then the standard deviation was the square root of 62.4, isn't it? Right? Because 62.4 is sigma squared, that's the variance. So I'm going to do square root of 62.4, and then I'm going to do mu, which is 120. And that gets me 0.886, doesn't it? So probably it's going to be 0.886 to three significant figures. Does that make sense? Hashim Hussein, well done. You're pro, good stuff. Yeah? Cool, 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 good stuff. So yeah, we've done that. Now, yeah, I think these two questions are typically okay. They're not too bad. And now the next one is a probability distributions. And I think personally, these are quite tricky. So how do we feel about these types of questions here? Put a 0 if you think I have no clue what to do here. These types of questions I don't like at all. Or put a 10 if this is very easy, very straightforward. How long is this stream? It's meant to be about an hour. I've got three more questions to do, so I think it will probably be just over seven, maybe 7:15 at the latest. But yeah, cool. All right. So I'm just having a look at the chat so I can see zeros, I can see five, sixes. Okay, cool. So let's have a read of it anyway. So it says the discrete random variable D has the following probability distribution, right? So remember, these are your values here that your probability distribution takes. So it can either take 10, 20, 30, 40, or 50. And then these are the actual probabilities that you get for each corresponding input, as you could say, right? And it says where k is a constant, right? So we've got, for example, probability of you getting a 10 is k over 10, 20 k over 20, and so on and so forth, right? And part A says show that the value of k is 600 over 137. Now this is easy, this part anyway. You've got a table you've got a set of values that are probabilities. You know that all of them have to sum to 1, right? So all you're going to do to get 1 mark is you're going to say, well, because these are probabilities and this is the table, they have to all sum to 1. You're just going to set an equation and say that, well, k over 10 plus k over 20 plus k over 30 plus k over 40 plus k over 50 has to equal 1. And now we need to figure out what k is. Now, what I would do, I think the best thing to do here is instead of trying to get a common denominator, just take out the k. Take out the k, and you're going to have 1 over 10 plus 1 over 20 plus 1 over 30 plus 1 over 40, like that, plus 1 over 50, like that. And this is equal to 1. And that would mean that k is just equal to 1 divided by all of that, isn't it? So what I'll do, actually, I'm just going to call this, just because it's quite long to keep writing. I'm just going to call this whole thing capital X, for example, and then I'll bring this down. Let me move this down a bit. Like there, like that. And then yeah, let me I'm gonna call this X right here. This whole expression there is X. So I'm gonna just say K is equal to 1 over X, and I'll put it into my calculator and see what we get. So getting this here, where's my calculator? Calculator is right there. It's gonna be, let me just check the chat, make sure it's all good. Okay. So doing this, let me go to calculation. I'm going to do 1 over 10, 1 over 10 plus 1 over 20 plus 1 over 30, 1 over 30 plus 1 over 40, 1 over 40 plus 1 over 50. And what is that equal to? That's equal to 137 over 600. So to be fair, because I actually know what that is now, because I've calculated it, I'm just going to write this as 137 over 600, like that. And that would obviously mean that k is going to equal 600 over 137, which is what they wanted. So that's not too bad, right? That's just part A. That's 2 marks. And part B, I just got a tip. Nailin Fernando or Nalin Fernando, thank you so much for the £5. I really do appreciate it. I hope I pronounced your name correctly. Apologies if I didn't, but thank you so much. I'm just having a look at the chat as I go along. But yeah, thank you so much for that. I really appreciate it. And yeah, let me just zoom in a bit. I'm just zooming into the chat so I can see it a bit better. Okay, cool. All right, cool. So we've got this here. Let me just zoom out a bit. All right, cool. Okay. I'm just trying to do it so the video's not distracting me as well. All right, cool. So you've done that. Part B. Part B. Part B. These are where it gets a bit tricky, right? So you just see, scroll down a bit. All right. So it says find, oh no, I've missed a part actually. It says the random variable D1 and D2 are independent and they each have the same distribution D, right? It says find the probability that D1 plus D2 is equal to 80. Give your answer to 3 significant figures. So I'm going to screenshot this here. Let me just screenshot this. So I need to get going up and down. So I'll bring this here. What I'll do actually, I'll bring this here and then put this B over here. And then I'm going to get the tables as well. And by the way, we know what K is, by the way, so I'm going to bring that too. So this is our probability distribution, right? And they've told us that the random variable D1 and D2 are independent, right? And each have the same distribution as D. So we know we're looking at this table for D1 and D2. That's just the first one. D1 is the first one and D2 is the second one, right? So there are 2 events that were taken. And apparently we need the probability that the sum of these are 80, right? So if I look at this here, now, although it says sum, right? It's just 2 events. You just need to ask yourself, well, how can you get 80 with 2 separate events, right? According to this table. what do we need to do? Well, one scenario could mean, well, how can I get 80 from here? I could do a 30 and a 50, right? So one scenario could be the probability of 30 plus 50, right? Or another one could be the opposite, 50 plus 30, right? And then the final one, well, how can you get 80 again? Well, you can do 40 twice. 40 plus 40, like that. These are the three scenarios whereby you can get an 80 out, right? Now, how does this actually work? Remember, they told us that D1 and D2 are independent events, right? So we can actually multiply them. So for me, what this means actually is, well, it's a probability of 30 and the probability of 50, like that. And this is the probability of 50 and 30 and so on and so forth, right? And this is equal to probability of 40 and 40. So all we need to do is just figure out what these probabilities are, right? And obviously we know that and means to multiply. So we're just going to multiply them together. So if I look at the table, equals, 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 30 is k over 30, like that, times by, and then 50 is k over 50, obviously. And then this is the same thing, but the opposite way, the opposite order, like that. And then this one's going to be k over 40 times by k over 40. And these are the three scenarios whereby you can get an 80 if you've got two different events from this probability distribution D. Does that make sense, guys? We happy with that? Lupura, well done. Well done. Making sure we're all good. Okay. All right. So just making sure all good with that. Why not 40 40 again, Larry? It's a good question, right? Because if you think about it, why were we able to do 30 and 50 twice? It's because, well, in your first option, right, you had two scenarios for 30 and 50, right? You had two scenarios, and I could just see Adam El Kadri. Thank you so much for the $10. I really do appreciate it. Thank you. But yeah, just to continue, Larry, I think it was Larry that asked. You've got two options, 30 or 50, right? So you can alternate them. With 40, you only have one option, don't you? When you look at, there's only a 40 there, and then to get another 40 to make 80, you've also got that one. So just think of it as how many scenarios do I have at the start. For 30 and 50, I can swap them round because there are two options for your start, your first option. You can either do a 30 or a 50. Once you get a 40, there's no other option there. That's why you can only do it once. Does that make sense? I hope that makes sense for everyone else because even I always ask myself this question as well because it's a bit confusing. But just if you think of it like that, then it should make a bit more sense. But yeah. So these are the scenarios, right? And what I can do is say, well, fine. I know what I always do is, oh, I'm gonna call this number two. I'm gonna call this number three, like that. And then we know what k is, by the way. Don't forget, we know what k is. What was k? K was 600 over 137. Yeah, so I'm just gonna put that there. So I'll just put this here. K is equal to 600 over 137. Now, this is going to be k squared over, what's that? 3 times 5 is 15, 1500, like that. And then this is going to be k squared over 1500 again. So that looks like an 8. That's meant to be a 5. 1500 again. And then the last one is going to be k squared over 1600. So we've got three scenarios whereby we can get an 80. So what we can say then is what I always do, especially even when I'm teaching my GCSE students, right? I've got a probability that has different scenarios. D1 plus D2 D1 plus D2 equals 80 can either happen three ways. It can either happen option one, or option two, or option three. And we know what these options are. It's k squared over 1500, k squared over 1500 again. And then the last one is k squared over 1600, isn't it? And then we know that or just means that we have to add these together. So it's going to be plus plus like that. So all I need to do is just figure out what this is, right? And now, remember, we know what k is. Yeah, this live will be saved. It always uploads automatically after I end the stream. Yeah. So remember, k is 600 over 137, right? So I'm going to say k is equal to 600 over 137. And then I'm just going to say that the answer, then I'm going to get my calculator. K is 600 over 137 over 137. I'm going to store this and then I'm going to say, well, that's going to be uh answer squared. To be fair, I could just do 2 times it kind of, but I'll just do it like this because that's the way I've written it down. Answer squared over 1500 plus the same thing squared over 1500. Again, I could have just written 2 times that, doesn't matter though. Plus answer squared over 1600 like that. And I get that there, which is 0.037 blah, blah, blah. So just write this 705 over 18769. 18769. That's our answer. Does that make sense? And then to be fair, let me put it as a decimal because a lot of you guys have done it as well. Let me just put it as a decimal as well. So approximately, and then what is it? SD 0.0376. 0.0376. Does that make sense, guys? Happy with that? Why do we do or, Zainab? Because there are three scenarios. It's like saying, for example, if I flip a coin, what is the probability of me getting a head or a tail? It's either a head 0.5 or a tail 0.5. It's going to be one, isn't 100%, right? So if you've got multiple scenarios, right, and it's the same outcome, it's the same probability, then you have to add them. Does that make sense, Zainab? Hope that makes sense. Yeah? Okay. Cool. Cool. All right. So we've done that. I think that's okay from what I can see in the chat. And then you guys are you guys are killing me. Anyways, yeah, so we've done that. And then part C is 5 marks. So let's look at this here. So we grab this here, and then what does it say? It says a single observation of D is made. The value D is the common difference of an arithmetic sequence. The first four terms of this arithmetic sequence are the angles measured in degrees, right, of a quadrilateral cube. It says find the exact probability that the smallest angle of Q is more than 50 degrees. So again, we're looking at this probability distribution D, guys. So again, I'm going to get the table for that because that's what we need to reference, right? And remember, we still know what K is. So we've actually got the complete model for this distribution because we know what K is, right? So let's have a look at the question again. D single observation is D is made, right? And this value, whatever value you get, is the common difference of an arithmetic sequence. The first four terms of this sequence are angles measured in degrees and of a quadrilateral. So what we could do is let's actually list out the first four terms, right? We know from pure, remember, don't forget your pure knowledge, right? Put part C here. The first term of an arithmetic sequence is A. The next one will be A plus D. Just adding the common difference would be A plus 2D and then A plus 3D, right? Like that. And these are angles apparently, right? These are angles of a quadrilateral. So when I add these together, if I add these together, add and then add and then add, we know that this must equal 360 degrees, no? Because that's what angles in a quadrilateral add up to. So we can say this is equal to 360. Let me just move that out of the way. 360. Yeah? Okay. Cool. So now what we can do is just get an expression which simplifies this, and that's gonna relate our value A, which is the first term of this sequence here, and that also represents the angles, right? A represents the angles and D. So if I simplify this, how many A's do I have? I've got 1, 2, 3, 4. I've got 4 A's, so 4A here. And I've got how many D's? D plus 2D is 3D plus 3D is 60. And this is equal to 360. And then I can simplify that just by dividing by 2. I get 2A plus 3D is equal to 180. Now remember, this is an equation in terms of A and D. D, however, is an observation from this probability distribution here. And let's look at the question. It says, find the exact probability that the smallest angle of Q is more than 50 degrees. Well, what is the smallest angle of Q? It's going to be the first term of this sequence because remember, it says that the value of D is obtained is common difference, right? And A is the first angle and you keep adding the difference to get the other angles, right? So we need to figure out what would allow this to be more than 50 degrees. I remember this is dependent on D, right? Because it's from this equation here. So again, this is where the table comes in. Now, you can just do a bit of guesswork here. I'll just put it here. Now remember, we need the angle A to be more than 50. The smallest angle is the first term of this sequence, right? So what we could say then is, well, for example, if we choose an observation of D, right? Let's just say D is equal to 10, for example. Let's say D is equal to 10, then what will happen to this here? What will happen is that you're going to get 2A plus 3 lots of 10 is equal to 180. And if I take that, that's 3s 30, 2A is going to equal 150. And that means that A is equal to 75, right? So this is more than 50 degrees. So in this case, when we choose an observation of D is equal to 10, we get the angle, the smallest angle to be more than 50. So this is one way this can happen, right? So I'm just going to put this to the side here. And remember, the probability of you getting a 10 from the table is K over 10. So I'm going to put this here. And I'm going to call this option 1. Does that make sense so far what I'm doing? Danny. can you explain what the capital D is and what the lowercase d is? So the capital D basically is just so the lowercase d, I should say, is just your points of observations of this distribution here, right? So what we're saying here is that for the lowercase d, right? You have these options. Yeah, you've got the 10, 20, 30, 40, 50. These are just options. Think of it as like your X's, right? These are the options you can get. And then once you pick one of these options, they all have a probability that corresponds to each one. And that is what capital D is. So what we're saying here is that when your capital D is, for example, 10, this is K over 10. When it's 20, the probability is K over 20. So just think of these as your options that you start off with. Like, just for example, think of like a bag with counters, right? These are your counters, and then these are the probabilities that correspond to grabbing each of those counters. I hope that makes a bit of sense, because even me sometimes with these type of questions is a bit confusing, but I hope that makes a bit of sense. And that's how you should always think of these type of questions as well. Yeah, especially these probability distribution ones. The top row is your options, and then the bottom row is like your Y's, the outcomes that you get. Yeah, I hope that makes a bit of sense. So yeah, are we happy with this though? In terms of what I've done so far, in terms of the first one, probability of 10 is K over 10. That's going to be one scenario. Does that make sense, guys? I'm just going to wait for you guys to say yes or no. Let me just loud this up. Um. So yeah, are we happy with this though? In terms of what I've done? Okay, cool. By the way, let me just show you guys. I'm using a Mac, right? I'm using a Mac. This is a Mac Pro. I think it's like a 15-inch. This one right here. I got it from my brother. It was his birthday the other day. So when I'm doing these live streams, I have another laptop that I used to see the chat, but my laptop wasn't turning on. So I asked if I could use it. But it's a serious laptop, so I'm taking extra care of it. But it's really good, to be fair. So yeah, I've never been a Mac person, but yeah, cool. So I think that's all good. So is capital D the probability? Yeah, capital D is the probability. Dahan does maths better. Capital D is the probability. So yeah, we've got that now. And then yeah, the next one is gonna be, let's try, remember, we'll try to see when the angle is greater than 50, when A is greater than 50. Let's try the next one. D is equal to 20. What happens there? That's going to be, remember, we're referencing this formula right here. 2A plus 3B is equal to 180, right? So it's going to be 2A plus 3 lots of, I'm just checking. Mate, you guys are ridiculous. 2A plus 3 lots of 20 is going to equal 180. And then we're going to see what A is when that happens, right? That's going to be 2A is equal to 180 take away 60, no? That's 60. And that's going to be 2A. 2A is going to equal 120. So A is equal to 60. And again, this is more than 50 degrees. So this is another scenario whereby this can happen. And the probability of you getting a 20 for that observation is K over 20, like that. And then now, what would the next one be? Well, 30, let's just see what happens when 30 happens, right? So D is equal to 30. That's going to be 2A plus 3 lots of 30. Like that is equal to 180. And then that's going to be 2A is going to equal 180 take away 90. And then that means that 2A is equal to 90. And that means that A is equal to 45, which is less than 50 degrees. So this is not an option, right? So, and obviously from the observations and what you can see, the higher D gets, the smaller A is going to become now. So there's only two values which are going to give us A to be more than 50 degrees. It's going to be when we choose 10 to be K over 10 and choose 20 to be K over 20, right? So it's going to be these two. So the answer to the question, so find the exact probability that the smallest angle of Q is more than 50 degrees. I'm going to just say probability of the smallest angle, which is A, is going to be more than 50 degrees, is going to be equal to probability of you getting a 10 for the observation of D, or the probability of you getting an option, or probability of 20 for the option for the table here, right? And we know the corresponding probabilities. They are K over 10 and K over 20. So I could put these here and say, well, this is just going to be then K over 10 plus K over 20, right? I remember we know what K is. I'm just doing it in terms of K because it's just easier to work with, right? K is equal to, what was K again? Do I have it? 67, 600 over 137? Yeah, K is 600 over 137, yeah? So let me just put this here. And let me just see. You guys can see, I'm just looking. Whoops. All right. I think this is all good. Didn't it say smallest angle? Yeah. Find well, exactly the smallest angle of Q is 50 degrees. The smallest angle is A. That is the smallest angle here. So we're looking at A, right? So we're just going to put this here. I remember K is equal to, let me just get it again, 67, or is it 600 over 137, sorry. 600 over 137, like that. So I'm just going to put this into my calculator and see what I get. So I'm going to go to calculation, clear that. Answer, whoops. How do I clear this? Oh yeah, it's going to be 600 over 137. That's what K is. And it's just going to be, I'm going to do answer over 10 plus answer over 20. And that gives me 90 over 137, or that there. 90 over 137. Does that make sense, guys? Just get my charger. Let's see this. You just see. Let me just see. Yeah. Are we happy with this, guys? Does it make sense? I'm just gonna make sure all okay. I'm just gonna wait for you guys to say yes or no. Just gonna check the messages, but I don't think there's anything there. Let me just see. But, solutions, and then okay, yeah. Yep. So I think that's all okay from what I can see. That's definitely correct. Is it when p equals 20 the smallest? Okay. You're pro. I think you're trolling. You're trolling. I think I know you as well. I feel like you're somebody I know as well. But yeah, let me just see. Why did A have to be less than 50? A wasn't less than 50. A had to be more than 50, right? Let's just look again quickly, right? Find the exact probability that the smallest angle of Q is more than 50. The smallest angle of Q is A, because remember, these are the four angles of a quadrilateral, right? It starts at A, then the next one's A plus D, A plus 2D, which is gonna be bigger. So A is the first term, which is A, right? Now this has to be more than 50. So what we did is we just figured out what the values of A would be given based on different observations of D. When D equals 10, it was 75. A was 75, which is more than 50. When it was 20, it was 60, which is more than 50. But once you get to 30, it becomes less than 50, right? And obviously, the bigger you go, the smaller A will get. So it's only the first two options. I hope that makes a bit sense now. Yeah? Couldn't see the Q, to be fair. Okay, my bad, my bad. Maybe I think I'm trying my best to like screenshot and stuff. And what I'll do is I will, for anybody that wants the link, I think I can actually send it. Let me know, guys. Can I send links in the live stream chat? If I can, then I'll send it and you'll get the mark scheme. But yeah, that's it. We've got two more questions. So probably gonna run over a bit. I don't think this one will take too long. And then we got a normal distribution one after. But yeah, binomial distribution hypothesis testing. What do we think about these guys? Put a 0 if you don't like these at all, or put 10 if these are light work. These are easy. Just checking. Yeah? Okay. It says I can. Somebody said I can. How do I? I'm using the Mac. I don't know how to use Macs, to be fair. How do I? Okay. I'm going to do it after. I'm going to do it after. Yeah? Okay. So, yeah. For anybody that wants the link, right? For anybody that wants the link, because I don't know how to really use this Mac well. I'm a Windows guy. But if you go to any of my other live streams, it's in the description, so you can get it there. For anybody that needs the link ASAP, I hope that makes sense. Yeah, Buna, I can see that. Buna, if you try that, then just let me know if that works out. Right, just go to any of my other videos, any live streams that I'm done, and you'll see the link in the description. It's a OneDrive link. Yeah. Okay. Let's have a look at this one. Part A says Africa works in a call center. She assumes that the calls are independent and knows from past experience that on each sales call that she makes, there is a probability of 1/6 that it's successful. That is successful, right? Africa makes 9 sales calls. Calculate the probability that at least 3 of these sales calls will be successful. All right. So again, what are we dealing with here? I'll say part A is right here. We've got a fixed probability, right? And we've got a sample size n, right? This is a binomial distribution. So I'm going to just say that x is going to be binomially distributed with n to be 9 and the probability to be 1/6, like that. And that asks us for the probability of at least 3. What is at least 3? That means probability of x being at least greater than or equal to 3. And we know this is the same as probability of 1 minus p x is less than or equal to 2. So again, this is not too bad. We're just going to put this into our calculator, aren't we? So let me bring this here. Let me just zoom out a bit and get my calculator. So I'm going to go to distribution, 7, and then binomial. I'm going to go to CD, aren't I? CD like that. And then 2 variable. And I'm going to plug in 2 because my calculator just gives it to me less than 2. And I'm going to put n for 9 and then p to be 1 over 6 like that. And then that gives me this value here. And then now I'm going to go to calculation, and that value is going to be stored. So it's going to be 1 minus that. I'll write out here. 1 minus 0.821, 82174, blah, blah, blah. And then that's going to be equal to 1 minus answer. That's going to be 0.178 to 3 significant figures. Does that make sense, guys? Happy with that? Yeah. Cool. All right, cool. So I think that's all okay. All right. So now part B, what's it say? Let me grab this actually. Let me grab this. So just so I have the question, just in case you guys can't see the question. This is this question here. And what do we know, by the way? Let me just put what we know in part A. We figured out that the probability or x is binomially distributed with n was 9 and this was 1 over 6, right? Now what did it say? It says the probability of Africa making a successful sales call in the is the same each day. Africa makes 9 sales calls on each of 5 different days. Calculate the probability that at least 3 of the sales calls will be successful in exactly one of these days. So this is another type of question that is very common, right? And you have to look closely because if you look at what we did in part A, let's just compare them, right? What did they ask us to do in part A? They asked us to calculate the probability that at least 3 of these sales calls will be successful, right? I'm going to highlight this actually as well. At least 3 of these sales calls will be successful. Part B says calculate probably that at least 3 of the sales calls will be successful, right? Can you see right there in yellow? Those are the exact same thing. So don't let it ever trip you out. This is just another binomial distribution, right? Well, we actually worked out what this is. We worked out this to be 0.178 approximately, yeah? And we're doing this on 5 different days. Can you see? Africa makes 9 sales calls, right? The same 9 sales calls that she made, right? On 5 different days. So we've actually just got another binomial distribution, but our n is going to be 5. N is going to equal 5 here. And the probability is going to be the probability if you get at least 3 of the sales calls to be successful when you make a sales call on 9 different days. On when you make 9 sales calls, sorry, right? And that is the probability that we figured out in part A. So part B is just another binomial distribution. And in our case, let's just look here. It's going to be binomially distributed with n to be 5, like that. So put 5 there. And the probability of making at least 3 successful sales calls, right? And that was 0.178 approximately. Does that make sense? And you want to do this on exactly one of these days. So you're just going to figure out probably if x is equal to 1. Does that make sense, guys? We happy with that? Yeah. Deb, good luck with bio. Thanks for joining. Sorry it's gonna overrun slightly, but I hope we're all okay with that. But yeah, so now all we're gonna do is just plug this in now. So what I'd always do, by the way, is that number there. I'm not gonna round it to 0.178. By the way, I'm gonna actually use this whole number in my distribution. So I'm gonna go to menu, and then 7, and then I'm gonna go to binomial PD because it's gonna be 4, and then 2, and then x is 1, and then n is 5, and then I'm gonna put the p to be answer, and that has the entire answer there, doesn't it? So I can put this in here, and that gives me 0.4066. And that's it for 2 marks. Does that make sense? Take care, Deb. Thanks for joining. Cool. Why is n to 45? Why is n not 45? Uh, oh, you're doing 9 times 5, right? Because Africa makes 9 sales calls, right? Remember, just look at part A, right? Africa makes 9 sales calls, right? N is 9 there, and the probability of you getting at least 3 to be successful is 0.178. So the 9 sales calls is just part of that binomial distribution that we did in part A. We're doing this on 5 different occasions. So in this case, N is 5. It's a bit weird to get your head around, right? But just think of it as this, right? The 9 sales calls, right? is from the other binomial distribution, and we calculated the probability of at least 3 of these cells to be successful. It was 0.178. We're doing this exact same experiment 5 times on 5 different days. So n is 5 here. Does that make a bit more sense? Yeah. Okay. Cool. Good stuff. Good stuff. All right. And then now, part C. This is the easiest part, guys. Binomial hypothesis testing, right? Let me copy this. Put this here. Right. It says Warren works in the same call center as Africa and believes he is more successful. Salesperson, right? To check Rowan's belief, Africa monitors the next 35 sales calls Rowan makes and finds that 11 of these sales calls are successful. Stating your hypotheses clearly, test at the 5% level of significance whether or not there is evidence to support Rowan's belief. Right now, it's so repetitive, guys. It's the same thing, right? Adam, thanks for joining, man. Appreciate it. Appreciate it. Okay, cool. So binomial distribution hypothesis is the same thing each time. Firstly, you're going to get 1 mark by stating the null and alternative hypothesis. We're going to call this H0 and we're going to call this H1. Right? Now let's have a look at the question. Warren works at the same call center as Africa and believes he's a more successful salesperson. Remember, the null hypothesis is what we know to be true. We know, based on Africa's experience, right, that the probability of her making a successful call is 1/6. So we're going to say P is equal to 1/6. Right? That's the null hypothesis, what we assume to be true. H1, let's see what Warren says. He believes that he is more successful than Africa, right? If he's more successful, then his probability is going to be greater. So it's going to be P is greater than 1/6. And this is a one-tail test, by the way. I always just put what type of tail it is when I get here. So this is a one-tail test, right? It's going in one direction. Now, this is the next part of the question, right? You've done the null hypothesis, you've done the alternative. It says to check Warren's belief, Africa monitors the next 35 sales calls Warren makes and finds that 11 of the sales are successful. So whenever you're doing these types of questions, guys, there's always, always, always an observed value here, right? So we're doing an investigation, right? There's 35, and it's going to be 35. That is n equals 35. That's the sample size that we're doing with this investigation. And and who finds it? Africa monitors calls Warren's. Okay, Africa finds that 11 of these sales calls are successful. So this is going to be your observed value. It's always the same thing. If anybody's not strong with hypothesis testing, just do maybe 5 or 6 in a row. It's so repetitive, right? So I'm going to say that the observed value is going to be equal to 11. Yeah. And then when you're doing a hypothesis test, you're basically trying to figure out the probability of observing this value, right? Given what you know to be true. And based on a parameter, which is going to be your significance level, you just decide whether or not it's significant or insignificant, right? And you just compare it with the significance level. So I'm going to say that the probability of observing this value, and remember, it's a one-tail test and it's going, and the probability is greater than, it's always the same direction here. So it's just something to memorize, right? Because it's greater than here, it's going to be probability of x is greater than or equal to 11 that I'm going to need to calculate, right? Based on the distribution that I know to be true, which is going to be n is going to be 35 and p is going to be 1/6. Does that make sense, guys? You happy with that? I'm just going to make sure we're all okay. Let me just go to the next one to see we're all good. Okay, cool, cool. I'm looking at the chat. I don't think there's no issues here. All right. So now you guys are funny. What are you guys talking about? Cool. I think on Wednesday, I'll do critical regions, but if I've got time after, I'll go back on this one as well. Yeah? Yeah, you can use the table. You can use the table to do probabilities. That's absolutely fine. You can use the table. And yeah, so I need to calculate this here. So it's going to be 1 minus the probability of x is less than or equal to 10. So I need to just calculate this to see what I get. So getting my calculator, I'm going to go to need to go to equals. I need to change this to 7. And I need to go to CD, isn't it? CD like that, and then 2. And then I'm gonna go to 10 because I'm looking for 10, less than or equal to 10. And then it's gonna be N is gonna be 35, and then P is gonna be 1/6, isn't it? So 1/6. Let me just do divided by 6. And then I get that there, and then I get this. So it's gonna be 1 minus that there, 0.9768. And then I'm going to figure out what that is. Now, if I go back to menu and then calculate answer, it's stored. 1 minus answer is equal to that there. So I get 0.0231, blah, blah, blah. and then you compare this with the significance level. The significance level is 5%, that's 0.05, right? So I'll put this here like that. And then what we can see is that this number, which is what we call our test statistic, is less than our significance level. And when that's the case, when it's less than, you reject the null hypothesis, right? So you're going to say, you're going to reject H0, reject H0, and you're just going to say this is statistically significant. And then what you do now is you need to contextualize this. You always need to write that final statement to get the final mark. Yeah? Did I write normal? Oh, sorry. I'm so sorry. I wrote normal. Apologies. That should be a B. Thank you for that. Thank you for that. Apologies. No, it's not normal, Aisha. Sorry. It's binomial. It's binomial. Apologies. But yeah. Does that make sense though? Are we happy with that? We've still got one more mark to get. I just want to make sure we're all okay. Yeah, you can, Elvin. You could figure out what the critical region is, right? And then you just compare your observed value to a critical region. And if your observed value is inside the critical region, then you reject it. You can definitely do that. Yeah? Elvin, I hope that makes sense. I'm just looking at your message. Okay. So yeah, cool. So now we've said it's statistically significant, right? And then now what you're going to do is write a concluding statement. So what was the claim? Rowan works in the same call center. He believes he is more successful, right? So what you're going to say is that there is evidence. There is evidence to suggest, right? To suggest Rowan is a more successful salesperson than Africa. And it will give you the marks. Yeah. Now, guys, it's the same thing each time. Again, if you're not strong on this, just do a couple. It's so repetitive, right? We happy with that? When do you know if it's binomial or normal? So Zainab, a couple of things you can look out for is when it's a normal distribution, there's always a mean, a standard deviation, and they will use the terms mu and sigma. When it's a binomial, you have a sample size, right? So can you see just throughout the question, we had n is 35. Africa made 9 sales calls, right? N was 35, well, sorry, from this one, from the hypothesis test, but 9 sales calls there. There was a probability, a fixed probability, right? When you see that fixed probability, right? That's when you know it's a binomial. So hope that makes sense. And this is an Edexcel question. Yeah? All right. Cool. Cool. We all happy with that, guys? Happy for me to go to the last question? Yeah. Stephanie, I'll definitely do a two-tailed test. I think I'll probably summarize it at the end, but I'll do a two-tailed test on Wednesday because I'm gonna do stats again as well. Yeah. But yeah, cool. So I'm gonna go to the last question that I've got now, and this is normal distribution. So we've got this here. I've just put in the parts here. So I've got this here. How do we find normal distributions, guys? Put a 0 if you don't like them, very difficult, or put a 10 if it's very, very easy, very straightforward. Really? Just go this here. Okay. Cool, cool. So yeah, let's have a start. I'm just having a look. You can see sevens, eights. I can't lie, six. All right, cool. So let's have a start then and see how we get on. So this one, it says a health center claims that the time a doctor spends with a patient can be modeled by a normal distribution with a mean of 10 minutes and a standard deviation of 4 minutes. Right? I haven't frozen, have I? No, I haven't. I haven't. Good stuff. Using this model, find the probability that the time spent with a randomly selected patient is more than 50 minutes. So again, this is just very, very straightforward one marker. Let me just zoom in a bit so I can see the chat a bit better. Um, okay, cool. So now, this is a normal distribution, isn't it? Right? So we're going to say X now is normally distributed. Now, generally speaking, it's mu for the mean and then sigma squared for the variance. In our case, it's going to be mean of 10, so 10 is going to go there. Standard deviation is 4, so 4 squared, like that. And they want probability of X being more than 15. So again, this is just very, very straightforward. You're going to put this into the calculator. So I'm going to put this in. It's going to give me 7, and then I'm going to go to binomial. Sorry, I'm going to go to normal CD, which is actually 2. And then the lower bound is going to be 15, and then the upper bound is going to be 10 to the power of 10, like that. And that is going to give me that there, and the standard deviation is 4, and the mean is 10. Putting this in, I get that there, and that is equal to three significant figures. That's 0.106, isn't it? 0.106. Oops, I need a 0 there. 0.6. Does that make sense? And also as well, it's always good to just draw the distribution out as well. This is always a good habit. I always just draw it, to be fair. So what we have here is that we've got the mean to be 10, and then yeah, we've got the standard deviation to be 4. And yeah, so if they ask us for greater than 15, then they're actually asking us for something here. And this area here, this area right here is apparently 0.16. Right. And that's pretty much it for 1 mark. You happy with that? Cool. Good stuff. All right. So we've done that. Part B. Let's have a read of it. Now, this is a hypothesis test. Again, very, very easy. Let me read this first and I'll show you that after. It says some patients complain that the mean time the doctor spends with a patient is more than 10 minutes. The receptionist takes a random sample of 20 patients and finds that the mean time doctor spends with patient is 11.5 minutes. Stating your hypothesis clearly and using a 5% significance level, test whether or not there is evidence to support the patient's claim. So again, this is a hypothesis test with a normal distribution, something that you need to memorize. I got this from the book, right? Let's read it. It says for a sample size of n taken from a random variable x, right? The sample mean x hat is normally distributed with the same mean, but you're going to divide the variance by the sample size. And this is something you've always got to do. So remember, in our case, x was normally distributed, right? With the mean to be 10 and the standard deviation to be 4, so 4 squared here. But we're dealing with a sample of 20 patients, right? So what we're going to do is say, well, the sample mean, right, is going to be normal distributed here, normally distributed with 10, and we're going to do 4 squared, and you're going to just divide this by the sample size, which is 20. That's it, right? Now, remember, let's have a look at, again. It says that some patients complain that the mean time the doctor spends with a patient is more than 10 minutes, right? So remember, again, we're dealing with a hypothesis test. We need, we need, what do we need? We need a null hypothesis and a alternative hypothesis, right? So I'm going to say H naught is going to be, what we know to be true. The mean is 10, right? And then H1, the alternative, is going to be what we're investigating, right? Some patients complain that the mean time is more than 10 minutes. So mu is going to be more than 10. And that's going to be, again, it's going to be a one-tailed test. Yeah? Yeah. I'm not sure, Ian, if this is in the formula book. I'm not sure. I got this from the actual book, the actual Edexcel book for stats, right? So, yeah. Now, remember, again, with normal distribution, sorry, there's always an observed value, right? Let's see what it says again. The receptionist takes a random sample of 20 patients and finds that the mean time the doctor spends with patients is 11.5 minutes. This is our observed mean. We're going to find the probability of observing this value based on what we know to be true. And we're going to compare that with our significance level. Yeah? So we need to figure out the probability of x, all right, x hat being greater than 11.5. Yeah, because remember it's one tailed to go in the same direction. So all we need to do is just work this out with this distribution here. This is the sample one, right? This is the one we're using. So all we're gonna do is just plug this in and see what we get. So I'm gonna put this in here, and then I'm gonna go to menu 7, and I'm gonna go to normal CD. The lower bound this time is gonna be 11.5. The upper bound is gonna be again 10 to the power of 10, a big number. Whoops, and then the standard deviation is gonna be the variance, remember the variance is sigma squared, that's 4 squared over 20. The standard deviation is going to square root that. Square root of 4 squared is 4, square root of 20 is root 20. So you're going to put 4 over root 20 into your calculator for sigma. So I'm going to do 4, and I'm going to do 4 divided by the square root of 20, like that. And that gives me that there, and then the mean is 10. And then I get this number here. And then this is going to be equal to 0.0467 6 blah blah blah. Does that make sense, guys? And then we just compare this with our significance level. Yeah. And then let me just see. Abra. Yeah, exactly. Exactly. Yeah. So significance level is what? 5%, 0.05. And that is less than. So therefore, again, because it's less than, we reject H0. Reject H0 and accept H1. You always just say, I always just say statistically significant. Statistically significant, right? And then remember, to get the final mark, you need to write a concluding statement. Dan can use the inverse function and the graphical for this question. So the inverse function is finding the area, isn't it? Right? The inverse function gives you an error if you have a specific probability. Because we're looking for a probability, you're just gonna use the normal distribution setting for this. Yeah? Okay. So right. So now we've got this here. Remember the concluded statement. What was going on here? Some patients were complaining about how long the doctor's taken for in this hospital, right? So we're gonna say that then based on that, to suggest there is evidence to suggest the doctor takes longer than 10 minutes. 10 minutes as the patients have said something like that, right? Just something that makes the examiner know that you understand what's going on here. You just bring it back to the actual question. Does that make sense, guys? Happy with that? Yeah. Okay. Cool. Just see. Let me just double check. Let me just see. See, done it wrong. Let me just see. Da, 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 da. Yeah. No, I think that's right. I've got the mark scheme, so. Oh, sorry. Yeah, yeah. My nines and fours, they look exactly the same. Sorry about that, guys. It's just something that I've always had. I've seen it a lot in the comments as well. Yeah, my fours and nines look very, very similar. Sorry about that. Yeah, yeah. Ferris gaming. Yeah, you could just do the critical region and just compare your observed value to the critical region. Absolutely fine. Yeah. So got this here, and then this is the next one. The questions that you guys have, I'm gonna just answer them maybe after. I'll try and answer a couple of them after I've done this question because this is the last one anyway. Yeah. So this one, got two more. It says the health center also claims that the time a dentist spends with a patient during a routine appointment, T minutes can be modeled by the normal distribution, where T is normally distributed with mean 5 and standard deviation 3.5. It says using this model, find the probability that a routine appointment with the dentist takes less than 2 minutes. That's very easy, just a one marker. So part C, T is normally distributed with 5 and 3.5 squared. So what we're doing is just working out probability of T being less than 2. That's not too bad. So I'll put this in my calculator. I can just go to equals to be fair, and then it's going to be that the lower bound is going to be let me move this here. The lower bound is going to be a very small number, minus 10 to the 10, 10 to the 10 like that. And then upper bound is going to be 2. And then the standard deviation is 3.5. And the mean is 5, isn't it? So I get this here. So it's going to be to three significant figures. It's going to be 0.196, isn't it? And what we're saying again, always just draw it out, just so you know what's going on here. Remember, the mean is 5, so that goes around here. And then 2 is there. And what we're saying is that this area here, right here, is 0.196. Make sense? Yep. Cool. Good stuff. And yeah, how come in normal distribution they standardize when doing a critical region without a need to? Yeah, you don't actually need to standardize, but I think it helps if you just know your standardization. Remember the mean is 0 and the mean is 0 and standard deviation is 1. It's just easy, and I think a lot of students do it, so I think that's why they do it in the mark scheme. But you don't actually have to do it. But yeah, whatever you prefer. So yeah, that's done. And then part double I says we need to find the probability that t is less than or equal to, sorry, t is less than 2, given that t is greater than 0 for 3 marks, right? So let's do this. Let me just move this down a bit because I've got one more to do after that as well. There. So what does that mean? Again, we've got another conditional probability. We saw this at the beginning of the live stream, right? Remember it? probability of A given that B happens is going to equal the intersection of these two, like that, over probability of B. So if I use that and I replace this with A and I replace this with B, then what does that actually mean? It means probability of T being less than 2, given that T is greater than 0, right, has to equal the probability of T being less than 2 intersecting with T being greater than 0, right, over the probability of T being greater than 0. Does that make sense, guys? Yeah? And then what you can do now for this one, right, is I like to visualize it as well. Again, I've got a normal distribution here, and I'm looking for this numerator here, right? Remember, the mean is 5. T less than 2 is going to be here, right? And then this needs to intersect when T is greater than 0. It's going to be probably around here. Well, when is T less than 2 and T greater than 0 at the same time? Surely it's just going to be in between these two, no? These right here, like that. So what I'm actually working out then is just a probability of T being in between 0 and 2. And that just makes things a lot easier. So I'll just say it's always a good habit, right? Just to actually draw the distribution so you can actually see what's going on here. But I hope that makes sense. I'm trying to make sure we're all okay with that. What I can see in the chat, I don't think anybody's got any questions about that. So yeah, I think that's okay. So yeah. I'm just gonna calculate these now and then see what I get for it. So putting this in my calculator, I'm going to go equals, and then what's my distribution again? Yeah, 3.5 is there, 5 is there, that's fine. And then I'm going to do it between 0 and 2. So 0 is going to be my lower bound, 2 is going to be my upper bound, and that's going to give me that there. 0.119, and then was it 119 again? Yeah, 119, sorry, blah, blah, blah. And I'm going to divide this by the probability of T being greater than 0. So what I'm going to do actually, let me just write that all out. What's that? 1192436. I'm just going to write it all out, yeah? Just so I have it, 2436, like that. And then I'm going to figure out what that is. So I'm going to go back here and I'm going to say, well, I need it to be greater than 0. So my lower bound is going to be 0 and my upper bound is going to be 10 to the 10. So this is me working out the denominator now. And that gives me that number there, 0.9 234. 234, blah, blah, blah. So I just to work that out. And what I'm going to do is I'm going to go back to my calculation setting. So calculation and then answer. I've got that number stored. I don't need to write it out again. So I'm going to do that divided by answer. And I'm going to just write the numerator in. So 0.199119, sorry. And then 2436. That gives me 0.129, isn't it, to three significant figures. And that's going to be our answer for that one. Does that make sense? Happy with that? Just gonna make sure all okay. I'm just gonna wait for you guys to just say yes or no, just so that we're all good. But hopefully that makes sense. I don't think it's too bad. Okay. All right, so you've done that, and then what is part? I think there was one more part actually. It says I, hence explain why the normal distribution may not be a good model for T. We'll always think about, if you see hence anyway, think about what you've just calculated, right? Firstly, we're using this model to calculate the probability that a routine appointment takes less than 2 minutes, right? And then the second one is that it takes less than 2 minutes, given that it takes more than 0 minutes. Well, if you're thinking about it contextually, shouldn't these be the same thing, right? We're dealing with the time it takes for a dentist to complete a routine appointment. And well, if it's less than 2 minutes, what did we get for this one? We got 0.196. And then when it's less than 2 minutes, but it's more than 0, we get a different probability, 0.129, which is a bit smaller, right? Well, why that doesn't really make sense in a contextual manner, in the sense where time has to be greater than 0, right? Why is it that when we put a restriction there, the probability gets smaller? What does it imply? It implies that there's going to be negative value, there's going to be probabilities for negative values of t, which doesn't make sense, right? So again, visualizing it is really, really helpful. What we're saying here is that, well, based on part I, the first part anyway, what we're saying, yeah, I've actually got this here, to be fair. I just realized I've actually got both of the graphs, which is actually really good, to be fair. So got this here, that's for the first answer, and I've got this here for the second answer, right? These shouldn't be different if you think about it, right? So what it implies is that I'll try to say uh part what does it say? It wasn't actually supposed to say. Hence explain why normal distribution is not a good model. Not a good model. So you just write not a good model as the two probabilities, all right, post short, implies that there are negative, there are probabilities, I should say, there are probabilities for negative values of t, right? Which is impossible because t has to be greater than 0. So you can say which is impossible. Does that make sense? Happy with that? These one markers are always a bit weird, but whenever you see hence, just try and follow the questions. Kind of think of it as like an English exam, right? We happy with that? Just before we go on to the last part? So yeah, it's probably just going to run over 7:30. Apologies. But remember, it did lag a bit, so it should have finished a bit earlier. But yeah, cool. So yeah, we've done that. All right. So I think that's all okay. I can't see the messages. So I'm going to continue now. And this is the last part. Last part of the stream. Let's see what it says. It says that the dentist, let me bring this down a bit actually. See. Um, what do you mean by negative values of t? So let me just explain that quickly. So remember, you're dealing with a normal distribution here, right? And this is 0 right here. This is 0 right here, right? If we look at this picture here, we could have, for example, that's going to be minus, I don't know, 0.1, for example. There's going to be probabilities for a negative value of t. So, for example, the probability of maybe, I don't know, t being less than minus 0.1 is something you can actually calculate, right? Let's just see. Where is it? This here, that there. By normal CD, what was it? Let's just say it's, let's say lower bound is minus 10 to the 10, like that, and then close that, and then that's minus 0.1, like that there. And then what was the standard deviation? 3.5 minus 5. You get a probability. The probability of t being less than minus 0.1 is 0.07. That doesn't make sense because the t represents the time that it takes for the dentist to complete a routine appointment. Does that make sense? I hope that makes sense now. Yeah. So that is why it's not a good model, because the two probabilities of t being less than 2 and t being less than 2, given that t is greater than 0, are different. That doesn't make sense. So I hope that makes a bit more sense in terms of what I mean when I say that you'll get probabilities for negative values of t. That shouldn't happen. Hope that makes sense. But yeah. So let's go to this question now, and let's see what we get, or let's see what it says anyway. It says the dentist believes that she cannot complete a routine appointment in less than 2 minutes. She suggests that the health center should use a refined model only including values of t greater than 2. Part D says find the median time for a routine appointment using this new model. Give your answer to giving your answer to one decimal place. Right? So again, visualizing these always helpful, right? Remember, t was normally distributed, right, with a mean of 5 and a standard deviation to be 3.5 squared. Sorry, standard deviation to be 3.5. The variance is 3.5 squared. Let's actually visualize that. We've got a graph here. We've got a bell curve, which looks like this. And we've got this here, like that. And what this lady is saying is that she can't do a routine appointment less than 2 minutes. That's too quick. She needs some time, right? So she's saying that we're going to use a new model whereby we're just going to be looking at values for t greater than 2. So remember, the median is here, and then 2 is over here, right? So I'm going to put this here. So basically, we've got a normal distribution, but we're only looking at these areas right here, right? Because we're only dealing with t being greater than 2, right? And what is the question asking us for? It says find the median time, sorry, for a routine appointment using this model, giving your answer giving your answer 1 dp. So the median time. What do we know about the median, guys, when we're dealing with a normal distribution? What do we know about the median? Anybody remember? The mean, median, and mode. What do we know about this? Symmetrical, right? It's halfway, it's 50%. Yeah. So what we're actually saying here is that there's going to be some value of t in this range, by the way, not for the whole thing, that, for example, is going to give us 50%, right? There's going to be some value of t that we need to find that will give us half of this here. You know what I'm going to do actually? I'm gonna highlight this in two parts, to be fair. I'm gonna highlight this part in green, like that there. Highlight that part in green. That's going to be one half of this, and then the other part I'll do in blue, right? And what we're saying here is that these two have to be split bang in the middle, right? There's some value of t which splits in the middle, and that is going to be the value of t that we're looking for. Federico, well done. Yeah, Lupura, well done. Yeah, so what we're saying is that there's some value of t that will give us 50% here. Of this, by the way, it's not going to be 0.5 of this, it's going to be 50% of this entire area, right? Now, what is that area though? Well, let's draw this one more time. Put this here. Remember, it's the same distribution, right? And we know that this is 2. T is less than 2. Well, remember, we actually figured that out. Remember, these are all sequential. These questions are all sequential. We worked out the probability of a root into point being less than 2 minutes to be 0.196. What I'm going to do is I'm going to get the actual full value out, right? So I'm going to just work out probability of t being less than 2. Let me go to equals. And it's going to be, lower bound's going to be minus 10 to 10. I'm going to put 2 here. And then that was that number right there. So I'm going to select this area here, right? This area right here is 0.196 or 195 blah blah blah, 195 blah blah blah. So this area here is going to be 1 minus that. So I'm going to do there, I'm going to do answer. It's stored. 1 minus answer gives me 0.804. So what I'm going to say then is that this area here, which we know we need half of, right here, this one right here, is going to be 0.804, right? This is 0.804. This area here, 0.804, blah, blah, blah. And we need half of this, right? Because we need a value for t, right? Which should give us half of this area here, right? So I'm going to just write this here. We need some value for t that splits this bang in the middle. So what we need to do is use our inverse normal, yeah? Because we're looking for a value of t given an area. So what I need to do essentially, which is pretty, it's not bad from here. I'm going to half this. Answer divided by 2 to half it gives me 0.4021. So what we're saying here is that if I look at this one, this is 0.4021 right there. And so is this one, like that. So we need the value of t which gives us that right there. Now, how do I get that area though? Well, if I do one more graph, right? Because on the inverse normal calculator, for my one anyway, it only gives me values which are less than. I need some value here. That's going to be 0.4021. And then this value here is going to be 1 minus that. That's going to be the value of t I'm looking for. So I'm going to just do 1 minus answer, and that gives me 0.597. So I need the value of t which gives me an area to the left to be 0.597. So what I'm going to do is I'm going to go to, remember I've got that number stored now. I'm going to go to 7, I'm going to go to 3 inverse normal. I'm going to go to area, which is going to be that number there, 0.597. The standard deviation is 3.5, and the mean is 5, isn't it? And I get that number there. So that number is the value that we're looking for. 5 point, what was it? 5.867. So the median time, right, therefore, median time is going to be 5.867. And that's it. Does that make sense, guys? So I think when you visualize it like that, it's really, really helpful. Yeah? Just gonna make sure all okay with this. Happy with this, guys? Just gonna wait for anyone to say yes or no. Let me just loud this up so I know it's working as well. Where's the sound? Hold on. Just gonna make sure all okay with this. Happy with this, guys? Okay, yeah, it's all good. Cool. All right. So I'm just looking at the chat. I can't see anything. I think that's all good. Does that make sense? I don't think these questions are too bad, to be fair. I think stats in general, it's a bit nice. It's a bit less demanding than pure. But yeah, cool, cool. So yeah, that's pretty much what I've got planned for today anyway. And yeah, tomorrow, Luke, tomorrow is mechanics. And that's gonna be at 12 p.m. tomorrow. 12 in the afternoon. That's gonna be tomorrow. And Gemma, why didn't you use 0.4021? Just based the reason why I didn't is because um I'm looking for this value of t right here, right? I'm looking for this value of t right here. And in my calculator, the inverse normal only gives me values to the left. So I still want this one here. But if I would have calculated the 0.4021, it's to the right. I need to do 1 minus to get this area on the left. So that is why I chose this one right here. Yeah, because that gives me, because the inverse normal just gives you, it's just default to area to the left. So that's why I used it instead of 0.4021. Yeah. Okay. Let me just say, I'm just looking. Okay. So can you go over it one more time? I'll just briefly go over it quickly, right? So again, we've got the dentist, right? We're looking for the value of t, the median time. We need a value of t which is going to split this area in half, right? 0.4021 on one side, 0.4021 on the other side, right? Now, I need to actually figure out what that value of t is. If this is 0.4021 on the right, then on the left, it's going to be 0.597. Just do one minus. And you're just going to do the inverse normal of that, right? And then what do you do for work? This is my job. I'm a full-time tutor. This is what I do full-time since I graduated. But yeah, I hope that makes sense. Wait, what do you think the grade boundaries are going to be this year? I'm actually not sure, if I'm being honest. I don't really know too much about the grade boundaries, if I'm being honest. But I'll just say, just do your best, and the grade boundaries won't matter. But yeah, hope that's all okay. And yeah, anybody have any questions on that? Again, I'll just let you know. Wednesday is going to be the last live stream. I'm going to do stats and mechanics. So if you guys have any questions that you want me to do on the live stream on Wednesday in particular, then yeah, you guys can just send it over to me, and I'll make sure I can try and do that. That will be at 7:30, by the way, on Wednesday. I've got on my live streams tab. You can see it scheduled, so you can just check there. But yeah, hope that's all good. But yeah, I think we'll leave it there. I think we'll leave it there. So let me just go back to there. Let me just, how do I go? I'm gonna go here now, and then I'm gonna go to big cam, and yeah, I think you guys can see me better now. But yeah, I should just say thanks for joining, and then again, there's two more live streams now. There's gonna be one tomorrow at 12 for mechanics, 12 p.m., and then the last one's gonna be Wednesday at 7:30, and obviously that's gonna be the last one before you do your last exam. But yeah, should I say thanks for joining? Really appreciate it. What I'm gonna do now is I'm gonna do the timestamps. So that will be done. Probably takes about an hour to do. So I'll do that, and then yeah, you guys will be able to watch this back at any time. But yeah, again, thanks for joining. I hope you found it beneficial, and I'll see you guys tomorrow for mechanics at 12 o'clock. Take care, guys. Goodbye.